Hello, good morning, and welcome everybody from Germany from my side. I'm gonna talk about today about something probably a bit different from most of the presentation at this conference because I'm looking more on the process side of things. This has to do because I'm from a large industrial company. So in addition to ensuring that in this continuous quality assurance, in this continuous delivery mode, we of course have to take care of the software, but there's a lot of additional things we need to take care of it. And this is what I'm gonna emphasize and present you how we're gonna tackle it with it in this talk. Maybe just a few words about myself. I'm a principal expert for PLM process innovation with Siemens Advanta Consultant. I have more than 15 years experience in driving lean and agile forward across industrial companies. And since now over 5 years, I'm actually dedicating my time fully to the so-called continuous delivery, DevOps topic, and pushing these things across forward in many different ways within Siemens. Externally, I also go to a lot of conferences and have exchanges on those things. And I'm always with a focus on how we can this apply to our, let's say, so-called industrial context. And this is also right point to give you maybe just a very brief insight into Siemens, just this one slide. Probably you all have heard the name and you know kind of Siemens. I mean, what we are coming from is 175 years of, so to speak, physical products. I mean, the products we're typically building and we are known of is like high-speed trains, subways. We build medical machines. We build mobility stuff. We build for factory automation and so on. So we are kind of coming from a world and still in a world where we have a lot of these physical products. But as you can see also, which is typically depicted in these slides, we also have a portfolio shift. So software is, of course, becoming more and more important also for us. This can be cloud solutions, on-premise software, but it also can be embedded software in the physical products. And this whole software area, I mean, this is not new. This has been a shift that's happening for the last decades, but this is becoming more and more important for our whole portfolio. And this is also the reasons why these, let's say, state-of-the-art approaches from the IT world, like continuous delivery, like DevOps, are also becoming more and more relevant for us, for a company like Siemens and similar, I would say, industrial companies outside. Maybe also to give you an indication on what we're talking here about regarding size. We have almost 300,000 employees worldwide. We have 60 billion of revenue. And even if you look at let's say, individual single business unit within Siemens, it's still huge numbers we're talking here about regarding revenue, regarding project sizes, regarding the product. What you also can see on this slide, this is something you maybe have not yet have heard of. This is the so-called Siemens Advanta division or business unit. Since last summer, we have also a service unit created within Siemens in addition to the units that are selling the products. And I'm part of this Siemens Advanta unit. And the reason why this has been created is actually really to drive this IoT topic, digitalization topic forward, and helping clients internally and externally of Siemens to really utilize these IoT abilities and to drive the digital transformation forward. And we, as a part of the process, let's say consultancy department where I'm a member of, are part of this overall Siemens Advanta unit, and I'm part of this whole transformation process. When we look at continuous delivery, continuous deployment, DevOps, in our context, as I pointed out, where we're coming from a heritage of legacy products, of large industrial systems, there's a key element in this whole transformation that we really need to tackle. And this is kind of can be summarized in this very brief statement. We have to stop thinking projects and we really have to start thinking a continuous value stream. And this is something that is extremely important, but it also has a huge impact on our whole, let's say, organization and the way we are dealing and the way we're coming from. I mean, what we basically have to move is shifting from this upper arrow that you can see here down to the lower part. So basically coming from this long, typically 1 year plus minus projects that we've been driven for the last 20, 30, 40 years in our R&D department, we really have to shift to this continuous value stream, as you are probably all aware of, and which you're probably very familiar with in your companies. And this is a tremendous change because everything kind of regarding on the way we work, on the processes side, on the organizational setup, responsibilities, interfaces, even let's say business models we've been dealing with has been kind of optimized more or less on the project type of approach. And if you really want to move to this continuous value stream, we have to rethink, redesign a lot about basically all of these things. What's also important in this picture for my presentation, when I like to talk about this continuous quality assurance approach we are implementing, if you look at the bottom part of this picture, the bottom arrow, I'm not talking about the initial phase, the lean startup phase, where you really bring something completely innovative new into the market. If we talk about this continuous quality assurance, frequent deployment, it's really after this minimum marketable product, after the initial market launch, and then maybe for the next 5, 10, or even 15 years, we have our products out in the field, and we want, in this sort of more continuous approach, to continually enhance the value of the product for the end customer by these frequent deployments. And if you look at this overall picture, this is like something we use a lot when you do this awareness presentation regarding the topic of continuous and DevOps in our company and in similar companies, is like a high-level architecture on how we have to move forward. And what is very, very important for us is that we really have to talk about what is our DevOps target scenario, because we have a huge, very heterogeneous portfolio. We have cloud solutions, but we also have safety critical physical products with embedded software, which are on-premise, where we have thousands or hundreds of thousands installations out there. And if you talk about continuously or more frequently updating those, these are different scenarios. I mean, it's all moving kind of in the same direction, and we are trying to apply these approaches, methodologies, and technologies, but the concrete implementation, the concrete deployment frequency, so to speak, differs between those scenarios. So for us, in our context, in industrial context, it's very important that you are clear about your DevOps target scenario, and this will not always be the same. And then we have a huge range of topics we need to address, like already mentioned earlier. We, of course, have to tackle these technology tool topics, architecture topics, and so on. But in addition, there is also a huge number of topics in the processes, organization, responsibility arena, all the way up to the business model. How do we sell the products in the future if we do more frequent updates? Is it then more a subscription model? How do we deal with our partners, with our suppliers? How do we integrate them in this frequent development, deployment, and operations process? So this is a very high-level view on this overall topic. And also, if you're interested to learn a little bit more about how this has been seen from an industrial company perspective, I have published a white paper just about a year ago, where I kind of summarize what you can see in this picture in a bit more detail. You can find the link at the end of the presentation. You can download it if you want and have a look at it. Today in the presentation, I want to dive deeper into a specific topic in the process part. This is a very, very important topic for us because, as I pointed out, coming from this project type of working, we also have implemented these milestones or quality gate, stage gate processes typically in these organizations. And we need to find a way how can we deal with it, or basically what is an adequate substitute? How can we replace these things from the past that are a mechanism to ensure the quality in order to transfer these, let's say, very valid criteria into a more continuous way. And this is what I want to dive deeper into now for the rest of the presentation. And we call it the continuous quality assurance approach for this continuous value stream. And what we basically have done over the last couple of years, we have come up with some ideas, some concepts. How can we transform or replace this milestone quality gate approach and transfer it in this more continuous world? And we have already implemented it in a couple of organizations. And this, from our point of view, is a very promising and the right approach on how to deal with this quality process issue in this continuous value stream world for an industrial or regulated company like ours. And on this slide, you can see kind of the core idea that is in this continuous quality assurance approach. As you are probably all very familiar with, at the bottom of the slide, the continuous integration line, where we can see the difference between project-based approach and continuous value stream approach. And I'm sure you're all very aware of this. If you are working on long projects, you have at the beginning no software. At the end, hopefully, you have successfully verified, validated, tested software, and then you can deploy it and provide it to the customer. In the continuous integration DevOps world, you work differently. You have this continuous integration delivery pipeline, these automated tests, the tool change, and you more work on the screen-to-screen approach, where you basically say, I have a system up and running, and I need, for every change I want to put into production, hopefully ideally 100% automated, I can verify that it's still green, that the change does not break the up and running software. And in our world, we also have to implement, of course, this sort of software stream. But in addition, we need a lot more things in order to be able to deploy, deliver a software release to a customer. It's not sufficient if we have perfectly functioning software. We also need a lot of additional things. I like to use the term non-software artifacts that we need to provide together with the software to our customer. And these non-software artifacts, they come from different sources. One of the sources, of course, the end user, the end customer. You need user documentation, potentially training. You need service documentation, installation guidelines. You need frequently asked questions for the hotline. You need marketing documentation. Maybe we talk about service level agreements and so on. There's a lot of these artifacts that come along with the software that is used by the end customers. Other are required from a regulatory purposes, safety certification, risk assessments, and so on. And yet others are maybe for our own benefit. For example, if you talk about patent applications, we want to make sure that we keep this intellectual property within the company. So we need to take care of patent applications. And in a project-based approach, where we're coming from, all of these non-software artifacts need also to be available by the end of the project when we release a software or a product, and the mechanism in the path that will ensure that we don't forget any of those is the milestone quality gate approach. And now if you look into the continuous value stream approach, our core idea is that we transfer this green-to-green approach that you have implemented on the software already for a decade. We also apply this green-to-green approach to the non-software artifacts. And it basically means we think, well, we already have a product out in the market. So we should already have a valid baseline of all these non-software artifacts from our initial minimum marketed product launch. And now for every change you want to implement, we of course need to look on the software side, but also on the non-software side, we need to answer the question, does this change break the baseline of the valid non-software artifact? It means, is any of these artifacts or documents becomes invalid in a sense that you need to update it because of the change. For example, if you add a new feature to the user interface, you need to update the user handbook, the user documentation, and so on, and similar with all the other ones. So we need to basically to check and analyze whether any of these artifacts becomes invalid. And if it becomes invalid, we actually need to update the artifact. So we need to be sure that this artifact, this non-software artifact, is updated before we deploy the change into production. This is very important. So this is basically kind of on a generic speaking, a similar approach. And on the software side, we coined the term continuous conformance for it. And as you can see on the next slide, So basically in the yellow part, this is just what we explained. In order for us to be in a position to have the ability for continuous or frequent deployments, we need to ensure two things. We need to have a tool chain implemented, a continuous integration, continuous delivery pipeline that takes care of the quality of the software, that ensures that a change does not break the existing software. And in addition, we also need to implement a continuous conformance stream that ensures the quality of the non-software artifact, basically meaning that a change does not break the or make any of the non-software artifacts that we need invalid. And if it makes it invalid, we need to ensure that this gets be updated before we can deploy. And both things are sort of on equal measures. Both are a prerequisite for continuous deployment. It's not sufficient if we have the perfectly working software. We also need to take care of the other things and vice versa. So we need to look at both of them. And this is a prerequisite to deploy a change into production. So you can see on this picture, when we looked at the, let's say, the previous milestones, and we looked at all the criteria that's taken care of there, we realized that there are quite a few things that we can decouple from these continuous deployment. For example, test strategy, configuration management plan, competence management. We need to take care of those things in a regular basis, but they are not linked to an individual deployment decision. So that's why we also have created these continuous marketing streams, where we say, yeah, we need to also ensure and take care of those topics on a regular basis, but it can be less frequently in this different mechanism and does not stop us from a frequent deployments as on the yellow part. If you now look how this can be implemented in practice, as always, it becomes a bit more complex, complicated, and you find out a few things that you need to take care of. And I want to outline this a little bit more in detail so you get a grasp on what it really means implementing this in your organization. Because initially we thought, well, what we want to achieve, for example, continuous or frequent deployment, we have our agile 2-week sprints. So let's try to achieve to be in a position to deploy after every sprint, after every 2 weeks. And what you already have in place are these frequent and continuous integration on a daily basis or multiple times per day. So we have this continuous integration loop running multiple times per day on the software side. And initially we thought our continuous conformance, well, let's just look at the beginning of the sprint, which do the analysis, which of the non-software artifacts need to be updated. And by the end of the sprint, just simply make sure that we have it all. But it quickly turned out that this is not possible for two reasons. First of all, a lot of these non-software artifacts, if you need to update them, they are input for the development. So we need to have the update of these artifacts if they need to be updated before the development can start. This is one reason. And the other reason is some of those criteria or non-software artifacts, if they need to be updated, it takes more than 2-week sprint. So for these two reasons, we actually have to take care of this earlier. And this is the second mantra from the software side, the shift left mantra. We also implement into our continuous quality assurance or continuous conformance approach, that we basically say, in addition to the green to green approach we have to apply here, we also have to implement the shift left approach. This is like shown schematically on this picture. This does not mean that at the beginning of the year we plan everything for the next 12 months. It still means that we have to work on these things continuously, but we need to be like one step ahead of the continuous integration development side with these non-software artifacts. So once we have everything, once we start the development or the team starts the development, the non-software topics are already taken care of in most cases. And if you now look even one step deeper into it, and then you look at these individual non-software artifacts, and you try to create, let's say, a process and identify when can I do the analysis, when do I need to do the update, who has to do it, who can do all this, who has the right competencies, and where do we have all this information stored. Again, it gets one step more complicated, because it turns out that there are very different types of non-software artifacts you need to take care of. And we identified 4 different types, and I can just quickly give you some example for all of them. When you look at the top, type number 1, it's, for example, a patent application. This is something that just takes a very long time. If we say yes for the upcoming change we want to implement, we need to rerun our patent application with the patent offices to ensure that this new feature, which is a cool new algorithm or something like that, does not get copied by other companies. This just takes a long time. So for these kind of criteria, we need to know far in advance whether any or this change impacts this, and if yes, we need to take care of the update of this at a quite early stage. There's only a few of them. Most of them are actually of the type 2, basically, for example, risk assessment or user interface, design description, or so on. If we identify that the change has an impact on any of those non-software artifacts, we need to update those before development starts because it's an input for development. And this is quite a large number of the non-software artifacts from this category. We also have, for example, type number 3. This is, for example, the end-user documentation. If we need to update the end-user documentation, maybe we need to add a new screenshot of a GUI. And of course, this can only be done, so this non-software artifact can only be finally updated during development once this has been realized on the software side. And the last one, which is a bit of an annoying one, the type number 4, is actually something, for example, open source component identification. Only during looking at the backlog item from a development point of view and deciding on how this is going to be implemented, you identify whether you need to rework on this non-software artifacts. So this is just a little bit to point out that I think the generic idea is fairly simple and straightforward what we have done. If you, of course, then implement this in practice, because of the diversity of these non-software artifacts, it gets a bit more complicated. So the question is on how can this be managed effectively. What you can also see in here on the right-hand side, which is something like a checklist or micro quality gate, so to speak, for the ready to develop. By implementing this continuous quality assurance, continuous conformance approach, we have a very much stricter definition of ready for the development team than in a typical agile development, where you basically say, well, it needs to be specified, acceptance criteria, testing, and so on. But we, in addition, say there are a lot of these continuous conformance aspects that need to be completed, the analysis, and in some cases also the update. And if this is not completed, if this is not ticked off, if this is not green, you are not allowed to pull this backlog item into the development sprint. So here we really have to live this, let's say, much stricter anti-criteria into the development teams than previously. So we have, again, the both sides. We need to have everything specified on the software level, but we also need to take care of the non-software level. And both things are of equal value or equally important in order before we start development. And then, of course, at the end, also for the ready to deploy decision. What is very crucial in this whole approach, and we had a look at this right from the beginning, because previously, as I pointed out, we have maybe a 12 months project where we have implementing maybe, I don't know, 100, 200 new features. It's a huge package, and by the end we have this quality gate or milestone checklist where we have 30, 40 criteria, and then there's a huge long process going through all these criteria and looking at the whole package and deciding whether this can be released, yes or no, whether all the quality criteria are met. Now what we basically have done, we chopped this into thousands of micro pieces, because we look at the changes individually, not as a whole package, and we also look at the criteria of these quality gates individually. And if you look at this, you basically now have to deal with hundreds of micro items, and to make sure that these things are looked at and they are kept track of. So we realized immediately that this cannot and should not be done with Excel sheet, but we really need to integrate this into the existing tool environment in order to have a transparent and efficient view on these continuous conformance aspect. And this is possible. And we made quite good progress on this one. And first of all, let's have a look a little bit at the figures and the numbers. I mean, what we've looked in here, like in a kind of a feasibility study already a couple of years ago, how many of these non-software artifacts do we actually need to update with an individual change? And what is depicted in here, two teams. We have team A that is implementing 8 features. Team B is implemented 16 features over the course of a Scale Agile framework planning increment. And we have these 20-odd continuous conformance criteria. And as I pointed out, we have these matrices where we need to look at each individual field and decide whether for feature 7, for example, do we need to update criteria 1, 2, 3, 4, yes or no. And here we basically mark it in a way that when we need an update due to a specific change or a new feature in this case, we mark the box with blue, and if not, it was left empty. And as you can see in here, a couple of things, and this made us very confident already when we started this whole process, that this is actually a feasible approach. First of all, typically it's 10 to 20% in the cases we need to update a non-software artifact, which actually means in 80-90%, the analysis will say, well, cool, you can implement this new feature, this specific non-software artifact can stay the same, it's still valid, you don't need to touch it. And this is, of course, understandable. I mean, if we have, for example, back-end changes or changes that increase the performance and so on, we don't need to take care of any of these end-user documentation and so on. And also, of course, like a patent application, for most of the changes we implement, we don't need to look at this again. And you can also see in this picture that some of the criteria are actually not affected at all, and others are affected quite frequently. For example, the end-user documentation is affected quite frequently, and also potentially like a risk assessment and so on. But this is how we deal it. And this whole items, we then integrated the management of these items, the tracking, the analysis, and the tracking whether it's been updated yes or no, which is a prerequisite for a deployment into the existing tool change. And at the moment, we have implemented in 2 tool chains based on the tool chains our customer were using. On one project, we have integrated into the IBM Rational Team Concert tool chain, and in the other project, on the Jira, they are using Jira. And at the moment, we're also working on integrating this whole continuous conformance process from a management point of view into Azure DevOps. And the way we do it is basically similar in all cases. We have something like a feature, or however you call your item, that is the entity you want to deploy into production. And we already have in these tools attached then user stories from a functional point, from a software point of view. And in the past, of course, in this tool chain, all user stories need to be completed successfully, and then the feature can be deployed. And now, based on everything I explained to you in the past 15 minutes, we now attach continuous conformance stories also to the feature, but only in those cases where we need an update. So we first have to do the analysis in the tool, and then basically for a specific feature, we need to go through all these continuous conformance criteria and to say, for this specific feature or change, does this specific non-software artifact needs to be updated, yes or no? It's a simple yes or no decision, and this is actually can be done quite quickly. And in Rational Team Concert, we realized it through adding an additional tab where we have all day pre-configured, and there's a simple drop-down menu. They basically say required and not required. And only if it's required, this continuous conformance story will get created. If not, we don't have these continuous conformance stories. So you can have features where you have 0 continuous conformance stories, and some of them have maybe a dozen or more, and most of them have a handful. And in Jira, we implemented it through the smart checklist approach. So we have created these smart checklists, and they are attached to these features or user stories created in Jira. And again, in the smart checklist, you can go through each of them and you can put them to invalid, you can delete them, you can skip them if the update is not required. And if it is required, you just leave it in to be done. And then, of course, you can, in both tools, you can, of course, work on this. You can track the status, you can put it in work, you can put it in done, you can assign names and persons to it and roles in the rational team console. And based off those, you can also have like a dashboard on the continuous conformance status of a specific change. So what we are really implementing in here is that we basically say we have an existing tool chain where we have the software in it, we have a dashboard for the green-to-green functionality quality of the software already implemented. In addition, now we implement the continuous conformance mechanism into this tool chain where we have all these non-software artifacts, and we also have a mechanism on how to analyze it, how to track it, and of course then we also have a dashboard where you can look at a specific change in addition to the software part of it, the non-software artifacts. What is the status? Is there still anything open? And of course, if there's still anything open, if not everything is green on this continuous conformance dashboard, you cannot deploy into production. And this is, from our point, a very, very promising and successful approach we are implementing that really helps us or enables us and similar industrial companies to move toward this more frequent deployments, and not only taking care of the software, but also taking care of all the non-software documentation, regular aspects in a comparable way and manageable way. Now, maybe let's have a look at the whole thing. I explained you, well, the key idea between the continuous quality assurance approach and concept. I explained you the how we manage it, that it gets a bit more complicated if you dive deep down into the trenches, if you look at the different criteria and think about what are the things, how can you be treated. And I also showed you or briefly summarized how this can be and must be and can be also integrated to an existing tool chain in order to be really able to work at this and to really then base your whole approach on this sort of dashboard type. So basically, if you look at this one, what you need to do in order to implement a continuous quality assurance approach, you need to look at these tool aspects that I just shown. But in addition, of course, it also needs to be integrated into the process. Who is doing what when? Do you have existing meetings? For example, this analysis we typically do on a weekly basis. We have product management and so on involved in this, also the security officer, the open source responsible person, the quality manager, the product owner, and they all fit together like every week on a continuous basis and look at the incoming changes on the backlog, on the product backlog. And in addition to looking at the content on the functional side of this backlog item, they also do the analysis for the non-functional topics on this continuous basis. And this, of course, needs to be integrated into your processes. We have, for example, integrated into the Scaled HR framework process applied by some of our business units, but this is not a prerequisite. You can, of course, also integrate it into your existing one. And because this whole is, at least for companies like ours, a very significant change, we also need to have something in place like a vision. Where do we want to move? We want to move from this project base to the continuous value stream approach. And in order to do so, we need to implement this continuous quality assurance approach. So we should really have this as an organization-wide vision, because it's not only the teams that are required to implement it, but also like technical documentation, the patent officer, all the so-called support functions we need to address these non-software artifacts. They also need to change the way they work with the teams. The interface need to be adapted. This is why it's extremely important that this is kind of driven, like almost from a CEO perspective, this change in order to move in this direction, so we can bring all required functions on board and really drive this change forward. So to summarize, maybe where we're coming from, as I pointed out, Siemens company, for example, creating high-speed trains or computer tomograph machines, but also providing a lot of cloud-based value-added services to factory optimization and power plants and so on. Yes, also our customers want products that get better every day they use them. This is, from my point of view, the key idea between this whole continuous delivery, continuous deployment DevOps approach. But extremely important, I mean, of course, it needs to have, let's say, the industrial grade quality. It needs to be safely, it needs to be securely, like what we did for the last 170 years. We cannot compromise on this. And therefore, we really need to ensure that it's not only the software that is really fine and working and being verified, but we also need to take care of all the things surrounding it. And like I mentioned, so-called non-software artifacts, they are equally important, and both need to come together hand in hand and need to fulfill this quality criteria. So this brings me towards the end. As I pointed out in the beginning, I have summarized this whole industrial challenges, so to speak, in this DevOps arena in this white paper. You can download it right now if you want, or click on the link later. And I'm also quite happy, of course, if you have any further question, you can contact me via email, or I'm also quite active on LinkedIn, and I'm happy to discuss this topic further with you, or look at your idea and receive your feedback. Okay, so thank you very much. Now we have a few more minutes left. I just have a check in the Q&A part. Are there any questions? I don't see any yet, so if you have some questions, please type them in the Q&A part, and we can spend a few minutes on discussing them. Okay. Well, it seems that there are no questions. Then thanks again very much for listening, and enjoy the rest of the day, and have a nice day, and maybe talk to you at some other point in time. Thank you.